Okay, you guys are probably seeing PowerPoint up on my screen now, and you're probably thinking to yourself, oh no, a boring lecture. Uh, but my aim here is actually to work out the logic for rock, paper, scissors prior to writing the Chapter 5 Game Zone solution. Um, you can go right to code, but I think that if you're getting a little bit more experience with coding, especially with a more complex problem, it really helps a lot to kind of sketch things out, and that's what we need to do here first. This is from Chapter 5, and the whole point of Chapter 5 is decision making. And we do that basically through two different structures, right? The one structure is if then else if, all that stuff. And the other one is case statements, right? So given a certain case, we take a certain action. And we can solve this problem using both methods, and really part of it will be up to you, ultimately. Um, if we are to describe how this game works, I'm hoping everybody's familiar with it. I can't make that assumption though. But the basic assumption is that you have three possible outcomes for two different players. You agree to randomly throw something out, so there's a keyword right there. And the three states are rock, paper, scissors. So you have the first player, you go rock, paper, scissors, you go 1, 2, 3, or whatever your little saying is to go with it, and then you both flash what you're going to choose. And given the different scenarios that occur, you have different outcomes.
So
The,
you've got 9 outcomes, 3 wins, 3 losses, and 3 draws.
all right. Say that again.
9 outcomes, 3 wins, 3 losses, and 3 draws.
Nine outcomes, three losses, three wins, and three draws. All right, so the scenario here is that if you each have three things to choose from, rock, paper, or scissors, so we can actually set up all the scenarios. Scenario one would be both have rock. Rock, rock. That equals a tie. All right, then we can do rock,
Scissors.
paper. I'm just going in the game order. What happens there?
Loss.
Okay, if you're the player, let's assume player, okay, human and computer. Primitive columns here. All right, so the other scenario is rock, scissors, and that's a win. All right, and then we go through the other scenarios. You don't want it to say wins. Okay, so we can do paper, rock, it's a win. Paper, paper, zip paper, paper, scissors. All right, do I need to finish this, or we get the idea? Maybe we should finish it. I have to make this assumption that maybe somebody out there doesn't know it. It's not quite enough space, is it? This is akin to ASCII art. Should have done it in a spreadsheet. So what does this equal? Result. One more.
So the pot is another pot.
All right. So we have a total of 9 possible outcomes. Okay, so we have to account for all those outcomes. One method might be to set up a case statement for each one of these. That would be an approach. I'm not sure that's the best approach. But maybe we can see, here's the beautiful thing about programming logic is that there's often many different paths to get to the same solution. So you can come up with a series of if statements. You can even do top-down logic. You can do loops. You can do case statements. Whatever gets you to the right answer is appropriate. Okay, so we were just talking about using case statements perhaps to solve this problem, which is one approach. But we're going to go back to actually figuring out how to play now. So we have one player chooses one thing. The other player chooses something else. In this case, we're playing the computer. For the computer to pick something, it has to do it randomly. So that's one thing that we're going to have to take into consideration. So we have to pick something. The computer has to pick something. And then we compare our results against this table to come up with the result. All right, so let's start with, and you'll have to apologize with this primitive flow charting here. And I'm just going to type in some stuff. Player, let's call it human picks. Okay, so you're going to pick one of the 3 possibilities. All right, so whatever you pick should be stored in a variable. All right, and what we're going to agree upon here, and I'm just going to kind of use this for a scratch area. Let's say 1 equals rock, 2 equals paper, 3 equals scissors. Can we agree to that? All right, so we pick something, and a good thing to do is to come up with a variable name. So let's choose a variable name for the human's choice. What do you think? Choice?
Choice 1, player, or player 1.
My choice.
My choice. My choice equals well, let's not give it a value right now. In fact, let's just, since we're kind of like pseudo coding, let's just say enter my choice. So Victor, you're saying I should go input equals my choice. I'm saying my choice should equal the input. So we're gonna whatever. Enter my choice. So whatever. We're just prompting the user for a choice. Okay, so the user enters a value, and then from there we need to make a decision right away. Right? So really what we need to do is just store the value, or can we move on to the next step logically?
Well, we can store it.
Okay. Yeah, you know, I'm just thinking here, if you're going to enter a choice, you're probably going to want to prompt the user to basically put in this information. Now, this isn't a very elegant tool, but this is what I have at my disposal. Okay, we're good?
Yep.
Well, then at that point, what happens next? We know, maybe this is a good way to do it.
Then we generate, yeah, we generate a computer's choice.
So what could we call that? So ours is called My Choice. What's the computer's? Can we just call it Computer Choice? Computer Choice. I'm really going to kind of truncate it here. All right. And this is going to be a variable name. All right, so the computer chooses, we choose, and then we start checking things, right? We agree? All right, so I'm just going to do a little arrow here. And if you remember in your flow charting, a decision is marked by a diamond. And I'm making it very large right now. I'm going to shrink these down. Just keep that in mind. Because I've almost filled my slide already. We're going to need a lot more room than that. All right, so what are we going to check first? Chris.
I would check to see that the user entered a valid number.
Okay. That is a great question. However,
So error validation?
yeah, and that's a great point. The point was to check to see if the user entered a valid value. All right. Now, if somebody does not enter something valid, then what would we do? We would do a loop. Have we reached the chapter on looping yet? No, sorry. So yes, if I was to write a program, that's exactly what I would do. I would ask for valid input and validate the input, and one tool that we use is a loop to go around and around. Let's assume that we have an intelligent user base.
That's a bad assumption.
Or if they don't enter a valid value, we could have it auto-generate one for them. I mean, that's another approach. So let's just assume they gave us valid input. What do we do first?
I would check to see if they're tied.
Okay. All right, so let's write a statement that goes with that. If tied,
My choice
okay, and yeah, that's a better way to do it. My choice equals
equals
comp choice,
equal.
and then I'm getting reminded I should do equal equal, which is probably a better form. There we go. Boy, that is not very pretty looking. And I'm going to change these to all right, so I think we're off to a good start.
You could just have like an else statement if they didn't enter one of those numbers.
And then what?
Have it do nothing, or have it go back.
You see, the whole thing is you can't go back without a loop.
In this case, the only way to do this is either.
Does Java have a thing like in VB where you just
Okay, so now that we're at a decision point and we check to see if your choice and the computer choices match, what would be the result of that?
Tie.
All right, so in that situation, we would have a tie, so we could have output,
Sticky tie.
well, that's large. Okay, so that would be the one result. If it's not a tie, then it's time for some more decisions, right? Now the question is, how do we accomplish that decision process? Else ifs and else ifs. All right, so would we need to go through the process now of setting up all the scenarios? So what do we check first?
I mean, and technically, unless you want to display,
Okay, so what we're bringing up here in class is how simple it's actually to determine whether or not the computer won or you won, right? Or if you want to create a scenario where you're giving a specific message for each scenario. Now, unfortunately, when we're running the program, we're going to need to show what the computer picked, right, in order to be able to determine if it actually worked or not. So one component of it's going to be you picked this, the computer picked that, rock beats, rock breaks scissors, you win, or something to that effect. So
Aren't you gonna need several statements though?
we're going to need several statements. It's going to be more than a couple.
Well,
Quite lengthy.
you could do when, it could be if my choice is less than computer choice, or my choice is the last one, computer choice is the first one. That'd just be one statement for when.
Right, but the messages should be different.
If you wanna do all the messages, you're probably better off just doing like 9 if statements.
Yeah, that's exactly what it's going to amount to, because really when you're playing a game, people want very specific
well,
output.
that seems.
So
Right, you just pick a number 1 through 3, and it either says you win, you lost, or you tied. That's not very fun.
no.
I mean,
Okay, somebody here is reminding me, what is the book actually asking for? Which is a smart thing to do. They're not, really they're not asking for a lot. It says, it goes through the rules. All right. It says create the game, let the user enter a number. We already accounted for that. Determine the winner, and that's it. It really isn't asking for a lot, technically.
It says, check if they're the same, check if they're, one of these results. That's the only thing it asks for, is one of these results. Rock beats scissors, scissors beats paper, paper beats rock. That's all
Right.
you technically have to display. And then which person won it if you got that.
Yeah, I think that's very simplistic. But I think that what we need to do here is like spell it out, but not go too overboard with it. We can go pretty overboard with it, but I want to make sure that we get all the logic in there. All right, so what I want to do at this point is I want to go back to this scenario, and we've already accounted for if they are a tie. We just output it's a tie and it's done, right? But what if it's not a tie? So if 1 equals rock, I think that's the first thing we should check. Would you guys agree? So if my choice is 1, then what are the possibilities for that?
Scissors or paper.
Right. We already know that if it's at this point, it's not, obviously the other one didn't choose 1, right? Because it wouldn't have come down to that point if it hadn't. So let's just say it is. Then what would happen? If I picked 1, I know the computer didn't,
Which equals.
right? So in that scenario,
When.
Wait, why would the computer not pick one if you didn't?
if I picked 1 and the computer picked 1, it would have stopped here and would have been a tie.
Oh.
But
Oh,
if
yeah.
my choice was 1 and the computer's wasn't, it would come down here. It would check to see if it's a 1. If it is, what would it check next?
If the computer choice.
If it's a 2 or a 3.
Yeah. Oh.
Does that make sense? And you can see I am really going to try to make this a little bit more compact here. Okay, so what's the scenario we're checking? At this point, we know what my choice is, right? So we are going to need to check the computer choice. So we already know the computer choice is not 1. So the first thing we should check is 2.
Well, it might make actually, in this weird sense, it actually makes more sense to check 3, because 3 is the actual win, whereas 2 is the loss.
Okay, so somebody's making the point here that it might make more sense to check 3 here instead of 2, because 3 is the win. All right, my logic is different because I'm just checking in numerical order, but that's absolutely fine logic. All right, so let's just assume
Right.
that is the case.
It's a win, else it's a loss.
That's where it's easier for if you check for 3, then you guarantee that if you didn't win here, then you've lost to the computer, because it wasn't a tie, you didn't win, so the only thing left is now a loss.
Or you
It's
can,
easier
or
to
you
check
can,
for a win than guarantee.
or you can
Okay.
check for 2, else it's a win.
Right, but,
Yeah, I mean, you guys are just trying to ration through either way.
right.
I mean, you can accommodate for any scenario in either way. They're really having quite a debate here about which is the right way to proceed. All right, so if the computer chooses 2, which is paper, and we've chosen rock, the output is, I would say rock. No, paper beats rock.
Yeah.
Right, yes, he's the
Paper
loss.
covers rock.
Paper
You're checking
beats
And then
rock.
in huge caps, you lose an exclamation.
Yes, and huge.
Shift 1 1 1 1.
You are a loser. Something like that, Victor?
Yeah, exactly.
Okay, well, let me throw in a little scenario because I'm thinking back to when we did this pseudocode in a different class. Up here, I mean, we're getting to the point here where we're putting out the message of like who wins or loses, correct? What would make sense to me from just like a user standpoint is we have the computer chooses, we choose, and then right in between here, we should have an output and the output should be just do an output of what happened. The user chose my choice and the computer, and I'm going to make this bigger because I know you guys can't see it, and the computer chose comp choice. And that way at least we have it on the screen as to what actually happened. And I'm just going to kind of move this stuff out of the way because I'm going to move it all down. Something PowerPoint was never designed for, right? All right, so you prompt the user puts in a value, you put it in a variable, computer randomly chooses something, and then you do an output of what you chose and what the computer chose. So you chose rock, computer chose scissors, and then you go through the selection process. If it was a tie, it'll output it's a tie. All right. In the scenario that I chose one and the computer chose two, we output paper beats rock. You were a loser.
Awesome.
No, we will paper beats rock, computer wins,
Ah, come on.
right?
Okay, yeah.
All right. The other possibility is what?
You are a winner. You win, right? Two.
If I chose,
Rock, beat, scissors, you win.
right. Rock beats scissors? Does that make sense, you guys? You see the logic? If we get to this point and it's true, then I chose rock. So the human side is always rock. We get down here, we check to see if the computer chose two is paper. If it did choose paper, paper beats rock. Otherwise, it must have chosen scissors.
Yeah.
So rock beats scissors. Okay? So that's kind of the termination of that branch of logic. All right. The next scenario would be the false of this one. And that will lead us to another decision, and that probably has to be much longer, I'm thinking. Darn primitive tool. All right, so if my choice is 1, right, the next logical one to check is 2. And this would probably list as an else if, because it's if, else if, else if. See how that works? So we would check 2. And then once again, we would kind of check in the same fashion. And I can see right now that all this stuff is not the right size or right distance. All right, so then we would also check what the computer did. So if we're at this point, we knew that if I came in with a 1, I would have gotten down to here and cut into this side. I would also have known that the computer could not have had 1, because if it did, it would never have gotten to here. All right? So in my situation, I would next check for 2, but what would I check next for computer? Because if it was a 2, and I had a 2, it would have already tied up here and popped out, right? So what would I check? What scenario would I check here? A 1. Does that make sense? I'll walk through it one more time. Let's just get this scenario in. And now I'm just going to copy this output statement. And I know this is kind of congested here, so. All right, so if I chose paper, 2 is paper, and the computer chose rock,
Yeah.
and really you should say paper covers rock, isn't that right? And rock breaks scissors, right? Hmm? Oh yeah. Yeah, well I wanted to come to a stop, so. Yeah, except you got to spell it right. Thanks for the sound effects, Victor.
You're welcome.
All right, so user wins.
And, yeah, that,
And this one's not right then, right? Rock breaks scissors, that's user wins. All right. So the alternate scenario here on this side would be what?
the computer chose the scissors, and so the user was the scissors cut paper.
Okay. So
Good paper.
so the computer chose, we know the computer, keep in mind, we know the computer didn't choose paper because otherwise we'd never be here, because in other words it would be tied with the human. So the only choices for the computer are either rock or scissors. So in this case, it chose rock. In this case, it's choosing scissors. Scissors cuts rock, cuts paper.
Cuts it.
It's very soft rock. And then who wins?
The computer was.
Computer wins. All right. And then finally, I'm going to have to add a little bit more on here.
It's too much. It's too much. She can't handle it.
All right, so this decision's going to come off the side here. Now what I'm going to do is I'm going to like zoom out so you guys can see the structure I've created here. And I'm just going to pick it up and move it this way. All right. And this, I know this is not very pretty. If I had Visio loaded on here, I'd probably use that instead. And even so, we need to pull this out a little bit. Okay. So the last scenario, okay, so here's the thing. If I chose 1, if I chose 2, do I even need to check if I chose 3?
No.
Nope, I can skip that part. So what I would check now is what the computer choice is. So if the computer choice, now keep in mind, at this point, if the user's choice is 3, the computer's can't be, right? So then we only need to check one scenario, which is, pick one, rock, yeah, 1 or 2, it doesn't matter. So I would probably see if it chose rock, because it numerically comes first. If it did choose rock, then we would do an output. And I'm kind of running out of space, so kind of being adjustable here. So if it chose rock, I chose scissors. 1 is rock, 3 is scissors. Rock breaks scissors. Who wins? Computer wins. Okay, the other scenario happens automatically. And the computer would have rock and we would have paper covers rock.
Scissors cuts paper. Maybe scissors cuts paper, because you have 3. And
Ah, yes.
Computer has 2, so you have scissors cuts paper, user wins.
Scissors cuts paper, user wins. Okay, and that covers all the scenarios, doesn't it?
Yep.
Okay, so if we do just a quick zoom out here, this is the whole logic tree. Covers all the scenarios. So it'd be, you get your input, or you prompt for input, computer chooses randomly, we do an output of what each side chose. The main reason we do that is so we can verify that the results are correct. Okay. Then at that point we check for a tie. If it's a tie, we're done. If it's not a tie, we check all the scenarios. So first we check to see if we have rock. If we do, then we check to see if the computer has either paper or scissors. If we don't have rock and we have paper, then we check to see if the computer's got rock, if it does. If not, it must have scissors, so we end up down here. And if I didn't have rock or paper, I must have scissors, so I don't have to ask if I have scissors. So in that case, I just need to check to see if the computer has chosen either rock breaks scissors, or if it chose, what's the other scenario, paper, in which case I have the scissors and cut the paper. Right. All right, so that's kind of the logic tree. Now, having this as a map will help us to work out the language of the if structure. So the way that this would look would be if, then, okay? Else if, then else if, and this would be true, this would be false. Now that would be the else if off of this one. Else if, true, false, else if, true, false. So you're going to have this really long else if, else if thing going on. Okay. The other possibility is that each one of these output boxes, and I count 7 of them, you could probably take a look at the scenarios created here, and I clicked on FileZilla by mistake, so I apologize. Remember we looked at this and we said there's 9 possible outcomes, but 3 of them are ties. So if you omit the 3 ties, it's actually 6 possible outcomes.
Yeah.
And the ties are all equivalent, so really it's 7 possible outcomes. So 1, 2, 3, 4, 5, 6, 7. So the other approach could be that you write case statements. So and I would actually leave the tie scenario for the default one at the end. So you could just say if computer chooses rock and I choose scissors, then you would just do a compound statement instead of a singular statement. So that's really kind of up to you how you want to proceed, but I do recommend that you, if you don't come up with your own pseudocode, then use mine. And what I can do is I can take this, clean up the image, and just post it right to the Blackboard shell. And that way you guys can build your code off of it. But once you have this, the rest of it is really just getting the random number generator and setting numbers, and then comparing them, and then doing a text output. And that will wrap it up for the pseudocode for rock, paper, scissors.